By now you may be wondering, where is the technology? We've seen a lot of information. Let's now move on to technology and online resources for disaster risk management. The objective of this session is to present you with some examples of technology, to present an overview of developing ICT solutions, and then to show an available online resource in the hope that you will search for others on your own. Let's examine this slide. Where is the technology? Okay, by now I'm sure you saw the big screen. Yes, that's an example of a flat screen television, and it is able to accommodate displays from many different sources and display them simultaneously. Can you spot any more technology in the room? Perhaps towards the right side of the image? If you see people holding cameras, those are the media, and they are using camera technology to transmit what is shown on that big screen display. This way, the public who is not present in that room is able to see what the decision makers seated in the foreground are looking at. Is there anything else in the room that resembles technology for you? Perhaps you notice on the table that there are microphones. So this is also technology that people use to confer with each other in the room. How about on the big screen itself? Maybe you see the maps and some smaller images on the lower left. The maps are a result of geographic information system processing of data, and they are displaying information relevant to the hazard. At this moment, I'm assuming it has to do with earthquake risk. The smaller images on the lower left, these are footage from closed-circuit televisions which are placed in different parts of the city that is having this type of control center. So then they're able to monitor what is seen by those cameras simultaneously. This is, in effect, what we call an emergency operations center or a disaster response control center, a disaster response control center. What we have here is a centralized area where information can come, and the people who make decisions as to where resources need to go in order to respond to the disaster are sent, and messages are transmitted to the corresponding institutions that have to deploy these resources, whether they're the health department or the civil defense or the fire department or the police. In effect, technology is enabling them to centralize a lot of the information that they need in order to make these decisions. But wait, there's one more type of technology that we haven't mentioned. And I think it would be the last one that you would guess. The people themselves are holders of technology. They know how the display works. They know the maps that they are looking at. And they know that those images on the left are footage from cameras. So then they are aware of the information that they are looking at and that it is transmitted to them for their use as decision makers in a disaster situation. So then they have this knowledge in their head, and this knowledge actually represents technology of a kind. I just wanted to point that out because we should not make the mistake of falling in love with equipment and buying equipment and forgetting that we also need to train people on how to use technology in the form of equipment. Okay, I think I've made my point. Let's move on and see some examples just very quickly. Databases and GIS. GIS was mentioned in a previous presentation, and it refers to geographic information systems. The database and the GIS are ways of storing different types of data inside a computer and retrieving them, and then doing some kind of a spatial analysis. Spatial is spelled as S-P-A-T-I-A-L. This means that we use their locations as a kind of input into the analysis. What we see here on the left are the different points where data were collected along a river. And then on the right, you see a small image of the flood plain of a river, with the river represented as a line in the center. And then in the middle is a long flow chart to indicate the kind of processing that data had to undergo in order to produce that river basin delineation. So we can use databases and GIS together in order to come out with that river basin delineation. There is a lot of computation, a lot of computer programming, especially of the formulas that hydrologists use in order to make these demarcations. And then the computer is able to do this within hours, even for a big river basin. So that's one example where we have two types of technology, database and GIS. The second slide, showing an example of technology, is one of sensors. Sensors are different types of measuring instruments, and they are deployed in locations so that they can measure real-life phenomena. This first setup is of a set of sensors that are used to measure how seismic energy can be transmitted. And if you can spot the laptop, that should tell you that the transmitted data are immediately saved onto a computer so that it can be analyzed. The next set of sensors are an array of many types of technology. We can see there are satellites and receiving stations on the ground. There's an aircraft that has some monitoring instruments. There are buoys that are deployed in the ocean, and they're also collecting data. You can see some ships. And what they're doing is trying to get enough data so that predictions can be made out of weather phenomena. All of this, and yet sometimes we're still not happy with the way our Met services are able to predict or not predict the weather. We can infer, therefore, that predicting the weather is complicated and that so much data has to be acquired in order to make some sense, some kind of rational prediction. And they rely very much on sensors. If you notice, this set of sensors is different from the one for measuring seismic activity, and it would be different again for measuring floods, for measuring landslides, for measuring volcanic activity, so on and so forth. So just assume that with every physical phenomenon, you will have to use a different set of sensors. Now, I would like to go a little bit into communication technology. We had heard about how SMS was used in a disaster situation in Haiti. Mobile phones are certainly becoming more and more popular. And for developing countries, the access to mobile phones is improving, so that we are now considering how to utilize this technology in order to improve the relay of information from the people we are supposed to serve to the disaster risk managers who are supposed to anticipate their needs. This is an interesting setup. The Community Tsunami Early Warning Center was set up after the Indian Ocean 2004 tsunami in Sri Lanka. Here we have a variety of technology that are used to receive alerts from the national agencies, and then the NGO that is operating the center is sending out the alerts to potentially affected communities via telephone, radio, internet, mounted speakers, and even handheld megaphones with volunteers going through the neighborhood spreading the alerts. This is a nice example of showing that we do need to consider multiple technologies in order to send out alerts, mostly because of geography, where we may have a wide dispersal of houses and other stakeholders who need to receive the alerts, and also because for developing countries, we cannot assume that their electricity will be functioning during a disaster event like a cyclone or heavy rainfall. There is a great potential for this infrastructure to fail. So then we try to send out alerts through multiple modes to ensure that everybody receives it. Finally, I'd like to show an online resource called the MDOT, or Emergency Database. This can be accessed by anyone, and it shows profiles of disaster events. It shows profiles of countries as well. So you can go to this page and you will find the location in your manual. And then you can check the disaster profile for your country. The application will show you the top 10 most destructive disaster events in your country in terms of number of people killed, number of people affected, and economic damage. It will also show profiles of the hazards themselves so that we can see for the Asian region, for example, what are the type of hazards that tend to kill the most number of people, that tend to affect the most number of people, or that tend to inflict the greatest economic damage. This is just one of the many web applications that you can find that will give you disaster-relevant information. I really encourage you to go and try it out if you haven't done so, and then try to find what the profile is for your country. And then I hope that you will use this as the beginning to keep yourself informed of your disaster risks and to inform other people. Thank you very much.